Hi, so we're doing lab 6, and the first thing I'm going to show you is my conformations that I did. So here I have my models. This would be my cis for my 1,2-dimethyl cyclohexane, and this is my trans for 1,2-dimethyl cyclohexane. And as you can see, I have an axial up and an axial down. And when I do my flip, I'm now left with an equatorial, up and an equatorial down. So that's how that changes on the model. And then I also have it right here on this paper. I don't know why this always goes fuzzy, but that was what I showed you. So it's most stable in the trans position, and we have two equatorial positions for that conformation. Then I'm going to go back and go over this mechanism for our isooctane with our chlorine, and I'm going to just do it again over here so you can see how I did. So for the initiation step, we have a chlorine and a chlorine. An electron moves from the bond to the atom, and we're left with two chlorine radicals. The first propagation step, we have our carbon chain right there, and then we're going to add, which is a non-radical, and then we're going to add a radical to that, which is our chlorine that we just got up here, and we will end up with, there's a hydrogen right here. It's going to attach right here because this is a tertiary hydrogen. There's 3 carbons coming off of that. And what happens is from the hydrogen, one of those electrons from that bond meets with the lone pair, or the single electron from the chlorine, and those make a bond, and then this electron left over just stays onto that molecule. So we're left with this as our free radical, our carbon as our free radical. There's my extra electron, and then hydrochloric acid. The next, or the other propagation step, is our carbon radical that we just made, and we're going to add it to a non-radical, which would be a chlorine-chlorine together. This electron from this bond stays on that, and this one comes all the way over here and bonds with this lone electron from that carbon chain. So then, that's how our chlorine is attached to our carbon chain, and then we're just left with a chlorine radical. And then for the termination step, it's just 2 radicals bonding together, and it actually just kind of stops the reaction. So we can have 3 options here. We'll have our chlorine radical, and our chlorine radical just make Cl2. We have our carbon chain radical and our chlorine radical, and that makes our carbon chain with our chlorine on it. And then the last one, or last possible option, would be our carbon radical and our carbon radical. And then they come together, they bond at those single electrons, and we're left, let's see if you can see this, they bond right here together, and that's where they make a bond, and that stops the reaction. So that was lab 6.